Now we are going to test one factor ANOVA, analysis of variance. Our null hypothesis is the average percentage of marks in all the boards are same. Here we have taken students ID, that means more or less serial number of the students or students ID, the board ICSC, CBSC and State Government Board of Secondary Education. And the board code is given 1 for ICSC and 2 for CBSC and 3 for State Government Board of Secondary Education. And the percentage of marks are given in the next column. We have to convert this into our software. After converting, it looks like this. Data view. Okay. So ID, the board, CBSC, ICSC and State Government Board of Secondary Education, the code, the marks in this way. Okay, variable view, and this is the string variable ID, board is string variable, code is numeric variable, and since 1, 2, 3 is given, and marks is also numeric variable. The values we have given 1 for ICSC, 2 for CBSC and 3 for State Government Board of Secondary Education. These are the scale variables. Now go to analyze, go to compare means and one-way ANOVA. Since we have taken the boards, the differences in boards is one factor, that is why it is one-way ANOVA. So dependent variable is scale variable, we have given the marks dependent variable, and this is the factor is code is factor variable. Okay. Now we have to put the contrasts. We don't need to take any change. Post hoc, since we have taken equal number of students or equal number of samples from each group, we can use 2 key. Okay. Similarly, if we are not sure that the variances are same in different populations, we can use Games Howell. Okay, continue, and options. We want to see the descriptive, the homogeneity of variance, the Welch and means plot also. Okay, continue. Now okay, our result is like this. The SPSS provides result in this way. This is our descriptive statistics, that means 3 types of boards, ICSC, CBSC and State Government Board of Secondary Education. The sample sizes are equal. The mean or average percentage of marks in different boards are given here. The standard deviation of the average value from each group is also given, and standard error 95% confidence interval for the mean is given. Our second test is given for test for homogeneity of variances. So the variances are homogeneous in various groups. This is accepted. Okay, this is accepted. So the variances are homogeneous, that means equal variances are accepted in various boards in population. Our ANOVA result shows the between groups and within groups value differ. If we take the division of these two, the F statistic is 3.382, which is, and the P value is 0.041, which is less than 0.05. That means significant. That means there exists significant difference in percentage of marks in board exam. Now the tests of equality of means, this is Welch test. Okay, since our the Levens test statistic is not significant, hence it is, we don't need to consider this robust test of equality of Welch test. We should concentrate on multiple comparisons. In multiple comparison, the dependent variable is marks ICSC, CBSC, the mean difference is 3.050, standard error is also given, is not significant. This p-value is greater than 0.05. But if we compare ICSC board and percentage of marks or mean marks on state government board of secondary education, it is significant. So difference of mean difference between ICSC and state board is significant. Similarly, if we compare the CBSC, ICSC, not significant. CBSC, state government board, is also not significant. Similarly, the state government board, ICSC, significant. State government board of secondary education and CBSC, not significant. So in this way, we can say that which one is different. So why the mean differences occurred in ANOVA, why the ANOVA result is significant. So here from this multiple comparison, it shows that state government board of secondary education differs from ICSC and CBSC. So it is given in homogeneous subset that we can put in one set the state government board of secondary education and CBSC, and in another set CBSC and ICSC. That means that there is no significant difference between within mean of CBSC and ICSC, and so it is given in one set, and another set the state government board of secondary education and CBSC. The mean plot also shows that ICSC, the mean value is too much higher. So graphical look. CBSC here, the mean of marks, and state government board of secondary education is here. So in this way, through Tukey multiple comparison, we can able to identify that which one is responsible for the mean difference among the groups.